Hi everybody, Mrs. Ross here. Let's talk science. Now, in talking science today, I wanted to talk to you about atoms, molecules, compounds, opposite attraction, like repellents, and lightning. To begin, I think it's going to be very difficult for us to just imagine what a positive ion looks like. So I borrowed this guy. He comes from a certain Uno game, and we're going to leave it nameless from there. But because he's green, he'll be positive. Because he's white, he'll be neutral. And because he's red, he'll be negative. Now, given our positive friend and our neutral friend, this would make up a positive ion. They don't really attract each other because neutral doesn't really attract positive. However, throw in a negative and you've got enough to cohere, to stick together, because as we know, a positive and a negative attract, and so they hold each other together. Now, when you think of this, I want you to think of the electron on the outside ring, constantly revolving around the center. And this positive ion, I want you to think about that actually as between the negative and the neutral, where the neutral is closer to what we would think of as a nucleus. It's in the center. So, red, negative, rotating around, positive, green, and neutral, red. But in real life, we don't just have one electron. And they're not always very well balanced. Sometimes what we have are two electrons, and all of a sudden we don't have balance. So if I have two electrons, one to the north, one to the south, both rotating or revolving around, and only one positive ion, what kind of charge would this ion carry? Two negative, one positive equals, that's right, a negatively charged ion. Because these two, they outweigh, they overtake it. There's not enough of the positive to go around. So we have a negative charge. But if we had two positive, one negative, and one neutral, then it would be, yep, you're right, it would be positive, because these two positive would outweigh the effect of the negative. Now let's talk about attraction and repellence. Attraction happens when you have a positively charged ion and a negatively charged ion that come together. They attract. They like one another. They say to each other, I like what you have because I don't have it. I like what's different about you. And so they pull each other together. Thus, static electricity. A shirt made out of one fabric and a shirt made out of another, rubbing together in the dryer create a baby shirt. No, they're rubbed together in the dryer and they create static electricity. So pulling them apart really hurts and they don't want to do it. Really hurts. However, two who are alike don't want to be anywhere near one another. They push each other apart every time they come close. And so, when you have two things that are made out of the same compound, they really don't want to be together. They really just want to separate and be independent of one another because they have their own identity. Okay? Like repel. Opposites attract. And thus, we have current. If you have opposites attracting right next to one another, they like to flow together. And we call that flowing current. And since these are electrically charged, it's an electric current, which is where we start talking about parallel and series circuits, which flew, or route electricity through them. Lastly, lightning. Lightning uses electric currents. Lightning says, I like the fact that I am mostly positive down here, and I like the fact that the cloud is mostly negative up there, and how am I going to get to that? I'm going to route myself through electric charge waves so that I can try and get to that negatively charged particle above me. So lightning is where one tries to get to the other, and it spears out just like a tree. There you go. I hope that simplified a couple things for you. You can feel free to watch this as many times as you need to help yourself understand, or never again. However, it's your choice. Talk to you in class. Bye-bye.